In part one of this lecture, we talked about principles of site design and talked about what should appear on a web page, what it should look like, and how we can address issues like accessibility. We also talked about project management and Web 2.0. In this part of the lecture, we're going to talk about the technical details. How do we design a site? How do we make a site look attractive? And we're going to introduce a new language called Cascading Style Sheets, or CSS. So in the previous lecture, we talked about how to use HTML for storing content and structure. And HTML is a wonderful language. Markup is great for representing the structure of a document. But it isn't perfect. In fact, it's ugly. It's really, really ugly. So let's see if we can do something about that. The first solution that we tried in the early days of the web was to do what we'd already done. In order to store content, we were using HTML. Hey, markup is great. Let's add more tags for doing presentation. And so we created a lot of pages that had things like this. I'm creating a new paragraph with a p tag, and in that paragraph, I'm going to style some of my text by putting it inside a font tag. And that font tag will set the color to blue and put the text in a 12-point serif font. And while I'm at it, why not tell the web browser to style that, to align it, to center it in a box that's 2 inches wide, and I'll underline the word hello, and then I'll put the word world after it without an underline. And now I can close my style tag, my bold tag, my font tag, and my paragraph tag. And this would work. It would display the words hello world with hello underlined in a blue 12-point serif font centered in a box 2 inches wide. However, there are a lot of problems with this approach. First of all, it leads to unreadable code. If you look at this, it's a mess of tags. If I wanted to make a change to the content, maybe instead of hello world, I want to say goodbye world, it's actually pretty hard to find where hello is so I can change it to goodbye. So not only does it lead to unreadable code, but it leads to unmaintainable code. We can't make changes to it to keep it working the way that we want. It also makes doing layout really hard. I don't have a way, if I'm using markup to style my elements, of saying put this here and put this here. The best that I can do is to adjust the sizes of things and insert lots of line breaks to try to kind of make them stack up the way that they're supposed to. But if I make a page look great on one browser, when I take it to somebody else's computer that has a different screen size and maybe even different set of fonts, it's going to look completely different and things aren't going to fit where they're supposed to. It makes my web pages really long. I'm adding all this extra markup. In fact, suppose that I had 3 or 4 different elements that I wanted to style the same way. I want to make them blue and put them in a 12-point serif font. If they're not all together in one big group or in one line of the page, I have to put these same tags in over and over and over again to make each one of them blue and in a 12-point font. I'm adding a lot of extra text to the page that doesn't actually mean anything. It just changes what it looks like. That may not seem like a big problem, but keep in mind that the more tags we add to the file, the larger the file becomes. It's going to take up more space on the hard drive, and it's going to take longer to download over the internet. So if we want pages to load quickly, we need to try to keep our files small. That's not easy to do if we're embedding our presentation elements as tags. Keep in mind that in the early days of the web, we were all connecting using dial-up anyway, so it was already slow, and this wasn't very noticeable. As high-speed internet became popular, we started to expect more responsive pages that would load quickly, and this became a bottleneck pretty quickly, having lots of extra tags we didn't need. So what's the underlying problem that causes all of these issues? Well, in computer science, we've learned from long experience that we ought to have separation of concerns in a program. What that means is that we ought to store our content in one file, some sort of data file, and in a language designed for storing content and structure. We ought to store our presentation elements in a separate file with a language designed for presentation and visual design. And if we want to make it interactive and have some control over those elements, we ought to do the programming and the code in perhaps a third file, in a third potential language, and we shouldn't try to combine them into one document. And so we weren't doing that in the early days of the web. But in the late 90s, we realized our mistake, And the W3C formed a working group to investigate options, and they proposed a standard called the Cascading Style Sheet Standard, or CSS. And CSS allows us to describe our presentation in an independent language. So we can now represent our content and our structure in HTML, and we can put our presentation elements maybe even in a different file, but in a different language designed specifically for presentation. So the key ideas behind CSS were to separate presentation from content and structure. We're going to do the content and structure in HTML. We're going to do the presentation in CSS. But also to allow web designers to style pages by applying general rules to multiple elements. Instead of going to each paragraph and saying, make this blue in 12-point font, make this one blue in 12-point font, make this one blue in 12-point font, we're going to be able to say, okay, make all paragraphs that are of this type blue and in a 12-point font. So we'll have one rule. We won't have to load it multiple times. Not only is this going to make our pages load faster, but it's going to be much more readable and maintainable. And finally, they wanted to make the language extensible so new features could easily be added because they wanted to future-proof the web. They knew that down the road there would be new things we wanted to do with CSS, and so they made it easy to extend. So we also had to make some changes to HTML so that we could use CSS with it. And one of the things that we did is we made a way for you to pull in a style sheet and apply it to a web page, and that's done with a link tag. A link tag typically goes in the head section of a document between a head and a /head tag, and it has to have two attributes. So the first attribute is a rel attribute that says this is a link related to, in this case, the style sheet. So whenever you pull in a style sheet, you're going to say link rel equals style sheet. And then the other attribute that you have to have is called an href, or a reference. And basically what that means is it's a file name that tells it how to find the style sheet. So in this case, we're going to pull in a style sheet named style.css. I've given you a third attribute here, a media attribute, which is optional. You don't have to include it. Its default value is all. It might be the case that we want a web page to look one way when we pull it up on the screen, but to look completely different if we print it. For example, if I'm giving a presentation, I might create a website that has a bunch of slides, but when I print them, I want them to print all on one continuous sheet. Or maybe I want to make them smaller so that I can fit multiple slides on one sheet of paper. So I could have one style sheet that shows how to display it when it's on the screen, and a different style sheet that shows how to display it when I'm printing it. If you want it to look the same everywhere, you can just say media equals all, or you can omit the media attribute altogether. Even though it's better to put your CSS, your presentation information, in a separate file, HTML still allows you to style things in the markup. So you can add a style attribute to pretty much any element, and you can embed CSS code directly in the tag. So for example, I could create a paragraph that has the style, the color is blue, and the font is a 12-point font, and that says this is big blue text. And that will actually work. It's not considered good design to do that, but you know, sometimes rules are made to be broken. Sometimes there's reasons that it might be better to do it this way than to follow the general principle that things should be separated. And so it's available if you need it. But typically, we're going to put CSS into a separate file. What is our CSS going to look like? Well, here's an example of a CSS file. It has two patterns. The first starts with A and says font size is 14 point, and the second pattern starts with P and sets the color to green and the font size to 10 points. Each of these patterns is made up of two parts. The first part is called the selector, and I've highlighted the selectors here in green. The selector A is going to match all links in a web page. If you remember, there's an A tag in HTML. That's how we link to another page. A stands for anchor. So this is going to match all links in the page and make them be 14 points in size. We also have a P selector. The P selector is going to apply to all P tags or paragraphs. It's going to make all of my paragraphs be green and in a small 10-point font. The other part of the pattern is the rule. So we have a selector and then we have a list of rules. In the A pattern, we have one rule that we set the font size to be 14 points. With the P selector, we actually have two rules. The first makes the color green and the second makes the font size be a 10-point font. So to be a little bit more specific and formal, a selector is a string that identifies an element or a group of elements in a website. Selectors can either be a tag name, which matches all elements of that type, and you've seen examples of this already, the A and the P tags, or we can identify elements on a page using their ID attribute, which will match all elements that have ID set to that particular value. So for example, here I've given you selectors for a main article ID and a toggle button ID. Notice that if you want to match an ID, we put a little pound sign in front, or what you're probably used to calling a hashtag now thanks to Twitter. So hash main article or hash toggle button will match an element in your web page that has the ID attribute set to main article or toggle button. So just to be clear, in the HTML, the hashtag won't show up. It'll just say, for example, main article. But in the CSS, we put a hashtag in front to identify it as an ID selector. IDs have to be unique. We'll talk more about that in a minute. Sometimes we want to match multiple things in a page. We can do that with a class attribute. And so we can specify that a CSS pattern should apply to a class of elements by saying dot and a class name. So dot title and dot citation, for example, would match any element in the title class or in the citation class. Here's some example HTML that we might want to style. Suppose that I have a paragraph and I've set its ID attribute to be main article. It says, this is the main article. And I have two paragraphs that are both in the citation class. I label them as being in the citation class by saying class equals citation. One of them is an article I wrote called How to Fail a Web Programming Course. Of course, I haven't really done that. That's why I've put it in the article of Useless Knowledge, the Journal of Useless Knowledge. And also, here we're citing Mark Twain's The Celebrated Jumping Frog of Calaveras County, which is a wonderful story that you should read from 1865. So if I now were to apply this style sheet that I show at the bottom of the slide to the text I showed you a minute ago, I'm going to take all of the paragraphs and I'm going to set them to be a small 10-point font. And then I'm going to apply to the main article paragraph the color green. So I'm going to make anything with ID main article green. That's that first paragraph. And anything in the citation class I'm going to make red, because I've said dot citation, curly braces, color colon red. By the way, notice the syntax here. I have my selector, then I have opening and closing curly braces, and between those curly braces I put my rules. All of the rules are of the format key, colon, value, semicolon. So all of those elements are important. You need to have the colon in the right place. You need to have the semicolon at the end. You need to have the curly braces in the right place, or this probably won't work the way it's supposed to. But when I apply it, it works. All the paragraphs are in a 10-point font. The first paragraph, which had the ID main article, is now green. And the two citations that were the paragraphs below, the bottom two paragraphs, are now colored red. So a little bit more about the attributes. An ID attribute has to be globally unique. That means that in one web page, I can only have one element that has that ID. If anything else has the same ID, I'm violating the HTML standard, and the browser may be unhappy, things probably won't work the way they're supposed to. So you can only have one element in the page that has that ID. That doesn't mean that you can have a paragraph with that ID and also a list with that ID. You can't have two things with the same ID at all. Only one thing in the page can have that ID. This is useful for something that only appears once in a page, like a logo, or sometimes you might have like a content pane, a main pane. And you're not going to have two of those, but you might have one. So you could set the ID attribute to identify that one thing. The class attribute can be shared by many elements. In fact, not only can many different elements be in the same class, but a single element can be in several different classes. So for example, I might have an author class. If maybe I've got a blog, and each blog post has a title and an author's name, and then the text of the blog. I could identify all of the authors as being in the author class, and I could style them all the same way. Maybe my blog has a little icon representing the user. I call that an avatar, and I could put those images in the avatar class. I might have a sidebar, which I might identify with the sidebar class. I might have multiple sidebars, one on the left, one on the right. I can also put an element into two different classes, and the way that's done is you just list them both and put a space in between. So here I could list the text of my blog as being both a blog post and being important. And if I said blog post important for the class attribute, it would not only be in the blog post class, but it would also match the important class. Let me show you what that looks like. So here I've got 3 paragraphs. The first has the class attribute set to blog post. The second one has the class attribute set to blog post important. So that second paragraph is going to be in 2 classes. It's going to be in the blog post class. It's also going to be in the important class. The last paragraph is only in the important class. So it's not a blog post, it's only important. If I were to say .blog post, font weight bold, we're going to bold all of the things that are in the blog post class. So we're going to put in bold the first 2 paragraphs. The one that says this is an unimportant blog, and the one that says this is an important blog. If I say .important and set the color to red, anything that's labeled important will show up in red. So the important blog post will show up in red. This is an important blog. And the important paragraph that's not a blog post will show up in red. The one that says this is not a blog, but it's important. So that will look like this. Notice again, the bottom 2 paragraphs were marked important, so they're in red. The top 2 paragraphs were marked as blog posts, so they're bolded. Now, in order to apply these styles, I need some way to identify which sections of the page I want to modify and manipulate. I can do that with existing tags. I could use a paragraph tag or a list tag or maybe a table tag, and I could say, okay, group all these things together and make them all blue. But that's kind of an abuse of the HTML. The HTML elements each have a meaning and a purpose. And if I'm using them just to group things together for doing style, I'm going to clutter my HTML document with a bunch of tags that really shouldn't be there. So a better way to do this is introduce new tags whose only purpose is to identify different portions of the page for the purposes of presentation. And in HTML, we do that with 2 tags, the div tag and the span tag. The div tag and the span tag both have the same purpose. They label a set of elements and entities as belonging to a group. And we can apply CSS rules to that entire group and style them all the same way. However, they're slightly different in how they're implemented. The div tag is implemented as a block element. That means that it's a lot like a paragraph. When you create a div tag, the web browser is going to treat everything between the div and the slash div as one block unit, and it's going to insert a line break before that block and the line break after that block to separate them from the rest of the page. However, if I use a span tag, the span tag is considered an inline element. Everything I put between span and slash tag is going to be styled in the way that I want, but the web browser isn't going to modify the layout in any way. It's not going to insert any line breaks. So there's advantages and disadvantages to using block level elements and using inline elements. Sometimes you want a div tag, sometimes you want a span tag. We're going to learn more about that when we talk more about CSS layout in the next lecture. Notice that HTML5 also provides some new tags. In particular, it provides a tag named main that identifies the main content of a page. It provides an article tag that lets you say, okay, this is a blog post or an article. And you can have several different articles on your page. You can label something as being part of a sidebar. You can have a header at the top of the page or a footer at the bottom. And you can split things up into sections and subsections with the section tag. It actually adds some other tags for nav bars and other features that are common to a web page. I think there's a nav and /nav tag. Why is this useful? Well, we could, instead of using these tags, just create a bunch of divs and give them IDs or classes that identify what they're for. But if I do that one way and you do that another way, when I create a CSS template to style my page in a certain way, I won't be able to give it to you to use because you may use different class names or different ID names. But if you're using main, article, sidebar, header, footer, nav, and section, and I'm using those same tags, and I come up with a really great template that makes everything look great, I can just ship you my CSS file, you can drop it in with a link tag, and automatically your page looks nice. So this is a really neat thing. This is the beauty of standards. If we're all using the same standard tags, our code becomes interoperable, which again was one of our design principles. for Web 2.0. What happens if I have an element on the web page and two different CSS rules apply to it? For example, suppose I have a paragraph with the ID chapter 1, and I have a rule that sets paragraphs to be blue and things with the ID chapter 1 to be green. Actually, I think in my example I have it the other way around. I set paragraphs to be green, but I set things with ID chapter 1 to be blue. What color will the paragraph be? Well, here I've created an example where I have a paragraph with ID chapter 1 and the text chapter 1, and a paragraph with the ID chapter 2 and the text chapter 2. What's going to happen? Well, CSS has a kind of general rule of thumb that says more specific overrides more general. So a paragraph selector can apply to any paragraph. It's a very general tag. But # chapter 1 or hash chapter 1 only applies to elements that have a very specific ID. They have the ID set to chapter 1. So since that's more specific, it's going to override the rule for the paragraph. So the chapter 1 paragraph is going to be blue because the rule for chapter 1 will override the rule for paragraphs. But the chapter 2 text will still be green because the chapter 1 rule doesn't apply to it and all paragraphs are green. I can also combine CSS selectors to have more power and more expressiveness in my selection of elements. There's two ways to do that. One is by joining. If I put one selector and immediately after it with no spaces I put another selector, as I've done here with P and hash chapter 1, what's going to happen is that CSS is going to treat that like one tag, and it's only going to apply those rules to things that match both. So it's only going to apply to things that are paragraphs and have the ID set to chapter 1. Alternatively, I could join things together by putting a space between them, and that's called nesting. If I say P for paragraph and then a space, and then I say hash chapter 1, the browser is going to apply my rule only to things with ID chapter, or this is actually chapter 2 in my example, if they're inside a P tag, between a P and a /P tag. So in the first example, P hash chapter 1, it's only going to apply to tags that are paragraph tags that have their ID set to that specific ID, to chapter 1. In the second case, I have to have two tags, one nested inside the other. One that has ID chapter 2 that's inside a tag that's a paragraph tag. So if I were to have this style sheet with these two rules, any paragraph with ID chapter 1 will be put in a 20-point font. Any tag with ID chapter 2 that's inside a paragraph is going to be aligned to the center. So for example, here I have a paragraph with ID chapter 1 and the words hi. That's going to have a 20-point font because any paragraph with ID chapter 1 will be put in 20-point font. However, if I have a paragraph, and inside that paragraph I have a third level header tag, an H3 tag, and that H3 tag has the ID set to chapter 1, no styling will be applied because even though the ID is chapter 1, the ID isn't set to chapter 1 on the paragraph. The ID is set to chapter 1 on the H3 tag, and H3 is not a paragraph. On the other hand, if I have a paragraph, and inside that paragraph I have an H3 tag with ID set to chapter 2, now the text will be centered because my second rule will apply, my nested rule that says anything with ID chapter 2 that's inside a paragraph should be centered. So the word goodbye will appear centered because it has ID chapter 2 and it's inside a paragraph tag. On the other hand, if I create, say, an article tag and I set its ID to chapter 2, and I put a paragraph inside it, no styling will be applied now because the ID chapter 2 goes with the outside tag, not the inside tag. And my rule only matches things that have ID chapter 2 and are inside a paragraph tag. If I have a paragraph with ID chapter 1, and inside that I have an H3 tag with ID chapter 2, now both rules will apply. The 20-point font rule will apply because I have a paragraph that has the ID set to chapter 1. The centering rule will apply because inside a paragraph I have an element with ID set to chapter 2. CSS actually provides much more sophisticated queries, and we're not going to talk about all of them. I'm just going to really give you one more, and that's the greater than selector. The greater than selector allows me to combine two selectors into a new selector by specifying that one tag is an immediate child of the other. So with nesting, as long as I had a tag with a particular ID inside a paragraph, it didn't matter if there were other tags in between. But if I want to specify a tag that's an immediate child that's directly nested inside another tag, I can use greater than. So for example, here I can say the element with ID main screen directly contains a list item, and if that's the case, color it green. So if I have an LI tag that's inside a list, for example, with ID main screen, it's going to be colored green. So now look at the HTML at the bottom of the slide. Notice I have a div named main screen. Inside I have a UL, an unnumbered list with class navList, and inside that I have a list item with the text item 1. Will this text be colored green? No, because even though I have a list item inside an element that has ID main screen, it's not an immediate child. There's this UL tag in between, this unnumbered list. And so this rule doesn't apply because even though it's inside, it's not directly inside. However, if I change this a little bit and set my rule to match any UL tag that's a direct child of a main screen ID, now it will be colored green because the UL tag is directly nested inside the div with ID main screen. Selectors can be kind of complicated. I'm going to be putting up some reading on Monday about CSS selectors, and I encourage you to take your time reading through it and try to understand it as well as you can. If you have questions, please email me, and I'll try to explain it a little bit better to you over email. In addition to selectors that tell us what we want to apply a transformation to, we need to be able to specify what transformation to apply. We can do that with rules. So a rule describes some property that should be applied to the elements that match the selector. We write rules as key value pairs with a colon between the key and the value. The key is the name of the property that we want to change. It might be the color or the font size. The value represents a possible choice for that property. It might be blue or 20 point or 2 inches. So there are a whole bunch of CSS properties. The CSS3 standard is enormous. But some of the most important ones are the background color of an element, the text color of an element, we just write color, the border of an element, we could put a little box around something, the font size, family, weight, and style, whether to align that text to the left, to the right, or to the center, the width and height of an element, and whether it has any margins or padding. We're going to talk a lot more about width, height, margins, and padding in the next lecture when we talk about CSS layout. But in the meantime, let me just describe one thing, the units that we use to measure width and height. CSS actually supports several different units, excuse me, some of which you're probably familiar with, and some of which you may not be familiar with. For example, we can specify a width in inches using the in suffix. So for example, I can set the width of an element to be 3.75 inches by saying width colon 3.75 in. CSS3 also supports centimeters, the cm suffix. It also supports a unit called a point, or pt. A point is used typically in graphic design and in the printing industry, newspapers and magazines and leaflets and brochures. It's a measure that's equal to 1/72 of an inch. So that's 1/72 of an inch is 1 point. Why would that be useful? Well, it's useful mostly as a measure for fonts. So if you say that you have a font that's 12 points, that means that the width of a letter is 12/72 of an inch. In other words, it's 1/6 of an inch. And that means that if you typed the letter M, for example, 6 times, that would be 1 inch long. That row of M's would be 1 inch long, right? 6 M's together would make an inch. That's useful for figuring out how much text you can fit on a page. Pixels are another unit of measure. We have to be careful with those. A pixel is a dot on a computer screen. Every Every dot on the computer screen is 1 pixel wide. Pixels tend to be kind of a rectangular shape. You can't see them without a magnifying glass or a microscope. They're invisible to the naked eye because they're so small today. It used to be that you could actually see the pixels because we had low resolution screens, but that's no longer the case. You have to be very careful when you're using pixels as a measure. Excuse me. Because the size and shape of a pixel varies from screen to screen. For example, on a widescreen TV, 1 pixel looks very different than on a normal desktop computer or on a mobile device like a smartphone. So you can have a really high resolution screen that has very small pixels, and you can have a very low resolution screen that has very big pixels. You're going to get a distorted layout and a distorted image if you use pixels for your width or your height, and you don't really know what you're doing. You have to be very careful using pixels as a dimension. We can also use relative widths and relative heights. We can just put a percent after a number. So we could say, for example, to set the margin to 10% of the container. So if I've got a box that's 500 pixels wide, I could set the margin to be 10% of that. The margin would be 50 pixels wide. Another unit of measurement is the M. An M is the width of a letter M in the current font. So if I have a 12-point font, an M is going to be 1/6 of an inch. However, if I have a 24-point font, then an M would actually be 1/3 of an inch. So 1 M is the width of a letter. This is really useful when you're creating forms. For example, suppose I want to have a little box that they can type a username into. If I want to allow usernames that are up to 40 characters in length, I could make the width of my box be 40 M, 40 EM, or maybe 41 EM to leave a little wiggle room. And the username will just fit in the box. That's actually a really long username, but hey, it'll work. Another unit is the X. That's the height of an X in the current font. I think they picked the M because it's the widest letter. I'm not sure why they picked the X. I think either it's the smallest letter or it's a convenient size because it's exactly the height from the baseline to the midline of your font. But at any rate, M and X are supported by CSS3. Unfortunately, X is not supported by all browsers. Some browsers support M but not X. Almost all browsers, in fact, support the M as a unit of measure, but many of them do not support X as a unit of height. We can identify colors either using color names or using user-defined colors. The original CSS 2.0 standard supported 15 colors: black, white, gray, blue, purple, red, yellow, green, aqua, fuchsia, lime, maroon, navy, olive, silver, and teal. It's kind of an odd selection of colors, but that's what CSS 2.0 supported. When CSS 2.1 came out, they added a 16th color, the color orange. What that means, practically, is that some browsers don't support orange as a CSS color name, although most of them do. CSS3 is about to be standardized, or maybe just was standardized, released as an official standard. CSS3 actually adds a whole bunch of new colors. There's over 140 named colors in CSS3, including things like light green and dark gray. CSS3 color names are based on the X11 colors library from Unix, so that if you want to look up the color names, that's one place that you can find it. You can also create your own colors. The easiest way to do that is using the RGB function. The RGB function takes 3 parameters: an amount of red, an amount of green, and an amount of blue. RGB stands for red, green, blue. And it's based on what's called the additive model of light. So when we're using additive colors, things don't work quite the way you learned in elementary school. The pigments that you learned about in elementary school were used subtractive colors. So red plus blue in elementary school made purple, and red plus yellow made green. Your primary colors were red, blue, and yellow. With light, things are different. With additive colors, our primary colors are red, green, and blue. To get yellow, we have to add red and green. If we add red and blue, we get not purple, but magenta, which is sort of a lighter shade of purple. If we add blue and green, we get sort of a blue-green color we call cyan. So for example, I could specify the amount of red to be 200, the amount of green to be 200, and the amount of blue to be 255, and I'm going to get a color like this, a very light grayish blue. It's very hard to read on this white background, I'm sorry. But we have a lot of red and a lot of green, but we have even more blue. So it's mostly like a gray color, but it's going to be a little bit lighter. If I tell it to set the color to be RGB of 255, 255, 0, I'm going to get red plus green, and that makes yellow. I have no blue, So it's just red and green. That's going to give me a bright yellow. Again, it's hard to see on this light background. If I don't have any light at all, if I have no red light, no green light, and no blue light, 0, 0, 0, since I have no light, I have darkness, and darkness is black. So I can get black by saying RGB 0, 0, 0. Another way to specify the amounts of red, green, and blue is to use hexadecimal numbers. To do that, you put a little pound sign or a hash, and then you put 6 digits. Each pair of digits represents the amount of each color. Hexadecimal is a base 16 number system, and so instead of just the digits 0 through 9, we have the digits 0 through 9 and also the letters A, B, C, D, E, and F. So the biggest number is FF, the smallest number is 0, 0, and everything else is somewhere in between. So here, FF00FF is the same as 255 red, no green, and 255 blue. So red plus blue makes magenta, and that's the color that you see here on the slide. The web allows you to have a kind of shortcut for that. It's fairly common to want to have 2 digits that are the same for each color. So in CSS3, you can actually specify a 3-digit color, like I've done here, hashtag C90. And what it does is it doubles it for you. It'll automatically replace C90 with CC9900, which turns out to be a sort of brownish color. It's a lot of red, some green, and no blue. And red plus green makes a yellowish or a brownish color, and so we get a sort of orangey brown color. RGB isn't the only color model. There's also RGBA. The A stands for alpha, which is a Greek letter that we use to represent the amount of transparency. So if you have 2 objects that you've placed one on top of the other, you can make the top one sort of a see-through object by setting its alpha to be like 50% or 20%. 100% means fully opaque, you can't see through it. 0 means fully transparent, it's invisible. And somewhere in between would be like 20% or 30% or something like that. So it's red, green, blue, alpha. Red, green, and blue are still numbers from 0 to 255. The alpha is expressed as a percent from 0 to 100. So for example, if I said color : RGBA, and in parentheses I said 0, 255, 0, 50, that means no red, full blue, full green, no blue, and 50% transparent. So that would be a bright green that's 50% transparent. Another color model is the hue, saturation, lightness model, sometimes called the hue, saturation, brightness model, or HSL. There's also HSLA, which again adds alpha. This is the color model that's used when you have a color wheel. You've probably seen the little circular color wheels where you can pick kind of an angle around the circle, and that gives you your hue. And vertical angle, or angle of 0, is red. As you move around the circle, you move first toward increasing shades of green, and then from green you move to blue, and then you come back around from blue back to red. So an angle of 0 is red, an angle of 120 is green. Something between 0 and 120, like maybe an angle of 60, would be sort of half red, half green, which of course we know makes yellow, right? Red plus green makes yellow in this model of light. Something between 120 and between 240 is going to be between blue and green, so that would be like a cyan. Something between blue and red, something between 240 and 360, will be a magenta or a purple hue. So you can specify sort of the angle around the color wheel, that's your hue, and then you can specify how saturated it is. So is it going to have a lot of bright colors, or is it going to be kind of a faint color? So 0% is faint colors, more of a gray. 100% is full color. And everything else is sort of in between. So as the saturation gets lower, you get dimmer colors. As the saturation gets higher, you get brighter, more vibrant colors. And then a separate question is the lightness, which is on a scale from 0, black, to 100, white. So you can have vibrant dark colors and vibrant light colors, or you can have dim bright colors and dim, they say dim dark colors. Dark and dim seem like they're the same, but in this model they're actually slightly different. So for example, if I set a color to be HSL of 120, 100%, 25%, then I'll have a green, because 120 degrees is the pure green, that will be 100% saturated, so it'll be a vibrant green, but it's going to be a dark green because it's only 25% bright. On the other hand, I could say HSLA, which is going to have an alpha channel, 0, 30, 90, 0.5, and this would give me a red because this angle is 0, but because it's only 30% saturated, it's going to not be a very vibrant red. It's going to be kind of a grayish red or a pink. So this is how I can get a pink, and I can make it a light pink by making it a 90% brightness pink, and then I can set the transparency to 50% or to 0.5. In addition to being able to set the color, I can set properties of fonts. It's important to know some of the characteristics of fonts. The most important characteristic of a font is the font family. Fonts can belong to the serif family. This is the traditional font. Back in the days when we had to print books using lead dyes, we had to create those dyes using a chisel. You'd basically hammer out the shape of the letter with a chisel and a hammer, and so all the letters would have sharp corners. They'd be really pointy. That's called a serif font if the letters have sharp corners and they're pointy. Serif fonts are best on the printed page. If you're going to print something out, it's best to use a serif font because those sharp points make it easier to distinguish from one letter to another. However, on a computer screen, we don't need to use the chisel and the hammer anymore. But also, because we have pixels, and pixels kind of blur things together, those sharp, pointy serifs don't come out as crisp and clean, and they actually muddy the letters, making it harder to distinguish them. So on a computer screen, it's better to use a sans serif font, a smooth font, like the Arial font. Another family of fonts is the monospace font. Both serif and sans serif fonts use what's called kerning. That means that if I have a large letter next to a small letter, I'm going to squish the small letter closer to the larger letter to make it look a little bit better and to save a little bit of space on the page. Sometimes that's useful because it's prettier and it's easier to read, but occasionally I might want all the letters to be exactly the same width. Maybe that's so that they can line up in a grid. If I wanted to print something like a word search, I probably want nice, even columns of letters. I would probably need to use a monospace font. Monospace fonts are also typically used for code listings, for input and output, and for examples to kind of set them apart as like a typewriter font. An example of a monospace font is Microsoft's Courier font. Courier exists only on Windows and in Microsoft products because Microsoft actually has a copyright or a trademark on its fonts. So Times New Roman and Courier and a couple other fonts belong to Microsoft, and you can't just use them willy-nilly in the open source world. Two other familiar families of fonts are cursive fonts like Comic Sans. You should not use Comic Sans in any of your projects for this course. If you'd like to know why, Google Comic Sans considered harmful. I'm not going to talk more about that. And fantasy fonts like Impact, which are mostly used in graphic design. In addition to being part of a font family, fonts have weight. That's how dark they are. Fonts can be either normal weight or bold. They can actually in HTML be bolder weight, which is even darker. They can be lighter. Or if you want more control, you can specify a number from 100 to 900. However, it has to end with 2 zeros. So it can be 100, 200, 300, all the way up to 900. That means that there's 9 different levels of boldness that you can choose from for your font weight. Fonts also have a style. That's either normal, which means straight up and down, italic, which means slightly slanted, or oblique, which means very slanted. And they have size, which again we can specify in points or in pixels or even in inches. If you had like a really tall banner or like a logo across the top, you might want something like a 2-inch font, where each letter is 2 inches wide. So 3 points that you should take away from part 2 of this lecture. First of all, HTML should be used for storing content and giving it structure, not for marking it up for presentation and style. Instead, we should use CSS for presentation and only put content in the HTML. Within a CSS file, selectors identify a set of elements to match, and rules assign values to the properties of those elements that we've matched. Next time, we're going to talk about some advanced CSS features, like how to do layout with CSS. And then we're going to talk about things like media queries, which allow us to create web pages that look good not just on a desktop computer, but also on things like mobile devices and other unusual screens.